Hey guys, it's time for another math problem. Math problem a day, keeps the, the doctor away somehow. Okay, so we're practicing our way to our state, our national, our international math Olympiads, right? So we have another one. This is from Ed again at Solve My Maths on Twitter. He puts really, really great problems. Okay, so what's the missing angle between the two regular shapes? We're looking for this one, the little shaded one. And this figure is shown as an isosceles triangle, right? So we know these two sides are equal. We know these two angles are equal too. How do we go attacking a problem like this? So we know these are two regular shapes. The inner one, it's easy to count. It's a regular hexagon. This is a 5, I'm sorry. And the other one, well, I mean, counting is not that hard. It's a regular decagon, right? So all we have to do is find out um, how much these angles measure, right? How wide they are, right? Okay. Fortunately, there's a formula for that. So we know that whenever you have like a closed polygon, if you grab one vertex, you choose it, you draw all the diagonals coming from there. This one had 6 sides, but you could only do 4 triangles, right? Each triangle is always 180 degrees. So in this case, it would be 4 times 180. For the general case, if you have n sides, it would be n minus 2 times 180. That's the whole sum of all of the angles, right? But we want to know how much each one is, and all of them are equal. So we divide this by n, right? So in the case of the regular decagons, since it has 10 sides, so it will be 10 minus 2, that's 8, times 180 divided by 10. We could cancel the 10. This is simply 8 times 18, right? So 18 times 8, that's 60. I'm sorry. I wrote numbers wrong. That's 64, right? 144, right? No. Yes. Yes, of course, 184. I can't believe this is the hard part for me. Okay, so we know this whole angle right here, it's 144 degrees, okay? And we know each and every one of these is 180. We could do the same thing, but it's a really known fact, it's a really useful fact that a regular hexagon, when you draw the 3 diagonals, you divide the figure in 6 regular triangles, right? In 6 equilateral triangles. So every one of these is actually 60 degrees, and one angle of the whole hexagon is 120. Okay, so we get 60 right here. So all we have to do now is find the difference. 144 minus 60, right? So that's 84. Okay, so this one is 84. We could use another color, right? This one is 84. So this one is 84 too. So how much is 84 plus 84? That's 168. And we know that the complete triangle is 180 minus 168. That's 12 degrees. So this right here, 12 degrees, right? So this is a very basic, very simple math exercise on what we call angle hunting, right? So we're using everything we know about angles, mostly angles inside polygons, regular polygons, and we use that and we go ahead, right? This right here, having an isosceles triangle, is almost always there, right? You have to look for those triangles, right? They're some of your best friends out there. Okay. The thing is, Ed actually tweeted a second problem. Okay, and this is it right here. Yeah. So Ed himself says this version has more steps. So now we're looking for this one. How will we ever find that one, right? Um, So it does have more steps, but not that many. So useful facts. We use the all triangles have 180 degrees. That has a lot of little facts like the sum of the total angles on any polygon. And what we're gonna use here is the external angle, right? So what's the external angle? It's this one right here. Okay, so it's pretty simple actually. So we're gonna call ABC the measurements of the angles of the triangle, and we know that A plus B plus C equals 180 degrees, right? But since B and this little triangle, right, this little angle right here, I'm sorry, X are on the same line, they add up to 182, or 182, right? Not like blink, 180, 182, right? So what does this mean? A plus B plus C is 180, but B plus X is 180. So this means that A plus C is the same as X, right? So X, the external angle, is the same as the two internal angles that are not adjacent. How do you say that? Right? Okay, yeah. So if we use this right here, um, I'm gonna draw this right here. So the little pink one is external to this triangle right here. Oh, I'm sorry. And this triangle right here, right? So we have to find out how much the other two measure, but we already know that. We just found out that this one is 12 degrees and this one is 60, right? Because that it's diagonal on a regular hexagon. So it's pretty simple, right? 72. That's it. Okay. So a more difficult way to do this would be to find out how much is this. We would have to go through finding everything, and this is another little really nice trick. This one right here, um, it's actually no, it's not. Never mind. Yeah, so that's it. Never mind that. Yeah, that's it. So, that's it for tonight. There's problems all over my YouTube channel. Most of them are Spanish, but if you ever want one in English, I mean, um, I could give it a go, right? Okay. Until next time.